Alright, Chapter 9, Mastering Solidworks. Patterning and mirroring SolidWorks is a great tool to help you improve your efficiency. SolidWorks software provides many powerful platform types that also help you to accomplish design tasks. In addition to different types of patterns, some options enable functionality that you may have not considered. In this chapter, we will learn to use the pattern function in sketch mode, use mirror function sketch mode, use geometry pattern option, pattern mirror as bodies, understanding pattern faces, pattern fillets as they're with their parent geometry, using pattern types, creating appearance geometry and cosmetic patterns, discover 3D mirroring techniques. Patterning in sketches, you can use both patterning and mirroring functions in sketch mode. Although sketch patterns are not a preferred choice for the 3D patterning is generally more efficiency. The distinction between the patterning and mirroring in sketch mode is important when it comes to sketch performance. There are as many metrics as software performs. SolidWorks to work as performance is synonymous with speed. Sketch patterns have very diverse effects on speed that do not offer the same level of controls of feature patterns. You might hear on a lot of conflicting information about the features is better used for the different situation using coming for the second background. Often some of the functions such as sketch pattern is familiar with the caution or with the questions with the better approach is visible with offering without having a way of measuring how it is patterned. When in doubt, you can perform, you test for determining whether the features works best in given situation. To compare and performance various types of patterns, I made a series of 20 by 20 patterns using circles and squares and a hexagon. Patterns are both specific sketch patterns and feature patterns. And I created them with both verification on build, geometry pattern turn on and off. Verification on rebuild is an error checking setting that you can access through tools option. Performance geometry pattern is setting that applicable only to the features patterns that disables the intelligence in the pattern features. Table 9.1 show that the rebuild in second solid geometry created with the various types of patterns is measured by performance evaluation. Also found in the tools evaluate performance evaluation. This was formerly called feature statistics. Sketch patterns are as far slower than feature patterns by their factor about 10 times. Biggest speed reduction occurs when you use sketch patterns in conjunction verification on rebuild setting, especially with the number of sketch settings being pattern increased. Verification on rebuild. Verification on rebuild setting is the turned off given its face of the test against each of the neighbors. For example, if you see the model is self-intersecting, they turned off the virtual on verification on rebuild test. Each face against every other face of the model. On simple cube, the difference between on and off the 4 tests various 5 tests. On large models, it could be well different because between 4 tests and 1,000 tests. The type of the arrow that would catch it would be, for example, if you had a box shelled it out and removed it on the one face, then you put a large fillet on the outer edge, you would see that the inside shell break through outside of the fillet. The verification on rebuild will return on. This would cause an error. Verification on rebuild were turned off. The SolidWorks would allow this. You would have invalid geometry with no error. To examine it more in detail, open sample model chapter 9, verification on rebuild solid part. Of course, verification on rebuild turn on large models very closely for performance point of view. So it shows the property manager, tree list, default appearance, verification on rebuild. There's only a number of faces sketch relations being patterned significantly affect the speed of the pattern. Sketch patterns have taken the entire finished model. Includes sketch pattern single extruded feature for the using the sketch with the pattern due to the extruded cut. The sample permits then our downloaded material of the chapter for reference. Look at this file. Begin with reference 1 through reference 7. Most shocking data difference between sketch pattern and hex. When a pattern sketch costs with flat compared with a feature pattern single extruded hex. With each verification rebuild of 36 hundredths of a second compared to 126 seconds. Alright, pattern rebuild times 20 by 20 sketch and circle square hex, defaults, geometry pattern, verification on rebuild. Note, it is true for the multi-contour sketch for the cut is a slow process that may not be because of the pattern. Delete the sketch pattern relation. Doing a control Q checks the statistics and many of the test results they were very close. A big feature with many of the rest resulting faces will be slow regardless of the relation for the sketch and such patterns or not. Always keeping this general information about sketch patterns in mind. Sketch patterns are padded for rebuild speed. More faces created in any pattern, the longer it will take to rebuild. The more sketch relations sketch patterns has, the longer it takes to rebuild. Geometry pattern does improve the rebuild speed unless the special end condition like up to surface has been used. Verification on rebuild pat dramatically increases rebuild time with the number of faces, but for our list affected by feature patterns with extruded sketch patterns. Figure 9.1 shows one of the parts used in simple tests. On the interesting finding of the test was pattern extruded feature creates a situation where the end face of the extruded features have merged into a single face. The face could take 10 times the amount of time to rebuild as a pattern unmerged end faces. This is an inadvertent discovery. I'm sure you will make your own discoveries and investigate rebuild special end conditions, cuts through all up to face, up to next, and so on, as well as the difference between cuts and boss features. Further, using Instant 3D can be an impediment when you're editing very large sketches simply due to the effect of the previews. Alright, a pattern used in test, and it shows a block pattern. You should note that the situation simple tests cover the very limited scope because of the plate with the constant thickness geometry. Only option actually works, which it wouldn't if the plate verified the thickness through the holes. It's also test only through all end condition geometry pattern best used simply disable intelligent conditions. I believe many people use the random toggle trying to get patterns to work that Solidworks would otherwise not allow to work. I discussed geometry patterns option with more detail in this chapter. I wanted to start with the chapter with a discussion that get attention to the most common misperceptions of the sketch patterns and somehow better than they feature patterns. Debunking more sketch myths. People often say that the best practice to define sketch fully. I completely agree with this statement. However, I heard people say fully defined sketches solve faster with the rational being Solidworks must figure out them how to solve the undefined sketch, but fully defined sketch is already spelled out. Let's find out. Comparing the rebuild times fully defined sketch, completely undefined sketch. We've been performance evaluation, print, copy, refresh, chapter 9. We have sketch, X, Y, and Z, no relations and distances. In this example, I created a sketch 4x4 rectangular, usually fully defined sketch to add the dimension, and I copied and pasted the sketch, removed all the dimensions of relation. Figure 9.2 show the feature statistics result. Fully defined sketches are best practice, but not to be rebuild speed. Sketch relations are costly with a rebuild time point of view. Pattern sketch relations are even more costly. The rebuild time does not even come close to the time that it takes to fully define a sketch tool to create all the dimension relations. But in the first place, the combination of geometry and software hardware took about 30 seconds of CPU time to add relation to dimension. For most models have fewer than 50 features, you never notice the rebuild time and the price you pay with it. Certainly with the peace of mind you get with the having stability of a fully defined sketch. Large models will have hundreds of features use lots of very busy sketches. You can pay attention to how much information you put into the sketch and try to limit the sketch patterns, even elements such as sketch fillets, using a feature fillets instead where possible. Patterning a sketch. Sketch patterns are available tool. They are valid in few cases. They are truly necessary. It's best pre-select the sketch entity that you want to pattern before using sketch pattern tool. If you're not pre-select that after the property manager is open, you can select the entities into the pattern 1 because of the window select is not available to this function. The right mouse button selection options select chains are not available in this interface, reinforcing the need to treat sketch patterns and pre-selecting features. Tip when creating a linear sketch pattern, be sure to select add spacing dimension checkboxes. If these dimensions are not added, then editing the pattern becomes more difficult. Using linear sketch pattern. Linear pattern property manager shown figure 9.3. Unlike on property manager, selected the sketch pattern functions are found in the bottom of the property manager instead of the top. This is like little confusing sketch tool property managers such as convert entity with a mirror, place the selection box at the top. The direction 1 panel works for the predictability establishing the direction and spacing and then the number. The angle setting it enables you to specify the direction, but it does not rely on anything outside of the sketch. For the direction 2 panel works look differently. You must first precise how many instances if you want, then other information will become available, the spacing and the grayed out, and until you tell it if you want more than one instant in the direction 2. Alright, linear pattern property manager, go to the linear pattern direction, dimension X, spacing X, and distance, instant count, angle, degree, X axis, Y axis, dimension, spacing, and count. 90-degree enables entities to pattern instances to skip. Using a circular sketch pattern. Circular sketch pattern option default for the sketch origin of the center of the pattern. You can move the position of this point using the numbers of the property manager, but you cannot dimension it until after the pattern is created. Again, this is another feature when you are needed to pre-select because the window is not available. Pattern sketch entities must be selected one by one going into the entities pattern panel. Figure 9.4 shows the circular pattern property manager. Show the parameters, x, y, and radiuses, angle of degrees, equal spacing, dimension radius, dimension angular spacing, display instant count, radial degree, curve angle, angle of degree. That needs the pattern, instances to sketch, skip. Alright, mirroring in a sketch. Mirroring in a sketch is a completely different pattern of the pattern in a sketch. It offers superior performance interfacing and is better developed. Mirrored entities in this sketch are instrumental parts in establishing design intent. Two methods of mirroring items in sketch are discussed here, along with a method to make entities work if they have been mirrored where in fact they were manually drawn. Using mirror entities. Using the mirror entities tool is two ways to the interface with or without the interface. Figure 9.5 shows the mirror entities property manager. If you pre-select the entities to be mirrored along the single center line, then click the mirror entities icon. You'll never see the property manager interface. The regular sketch entities will be mirrored about the single center line. So the selecting items mirror entities property manager message select entities to mirror sketch line near model edge plane or planar face to mirror about. Options entities to mirrors copy mirror about line, and then you put your line there. If you prefer to use interface, click the mirror icon first and then select the entities. If you use the method, you can mirror center lines as well as regular lines. You can select the regular line edge plane in the mirror about box. Also, you can turn off the copy option to the remove of the original entities when creating the mirror. Using the interface allows you much more flexibility. Avoid interface have special requirements, but it's much faster. Using dynamic mirror, as the name suggests, the dynamic mirror sketch of any they are created, you can activate by selecting center line, clicking the dynamic mirror button in the sketch toolbar. Dynamic mirror is not on the toolbar by default. You need to choose tool, customize command, add it to the toolbar. You can also access dynamic mirror by using tool, sketch tool, dynamic mirror from this menu. When you activate the function of the new no property manager interface, the center line display with the hash marks ends of the remains active until you turn off the exit of the sketch. Figure 9.6 shows these center line hatch marks. Using symmetry select sketch relation and editing the situation where you may not want to create new geometry will be existing any of the new relations driving them to create symmetry. Sketch relation, you must have two similar items such as lines, endpoint, center line, and a center line selected. To add symmetry relation with after have been properly selection, use the pop-up toolbar interface add relation toolbar button. Two options are shown in Figure 9.7. You can find more information manipulating sketch relations in Chapter 3, working with sketches and reference geometry. Two ways of adding a symmetrical sketch, and here's the make geometry, add relations selected at needs, existing relations underdefined. Add relations symmetrical or fixed. Using mirror and 3D sketches, Chapter 6. Get more from your sketches. Deals with the 3D sketch in more detail, but I discussed the mirror functionality here to connect it with the rest of the mirror and patterning topics. You can mirror sketch entities in 3D sketches when selecting 3D space or TD planes, but mirroring a 3D space requires a plane to the mirror about it. Then you can use the regular mirror entity tools, and then you can use the 2D sketches. Sketch patterns are unavailable in 3D sketch, but you can use or move or rotate copy sketch tools on the planes of 3D sketches. Working with 3D patterns, patterning 3D geometry with the components of the body of the features of the face is extremely powerful. It saves the design time and the compute time. The use of the correctly selected for the right type of the entities of the curve as the seed of the pattern can determine your success with this stitch function. One of the basic functions of the patterns determine the original instant seed from the pattern instances. They are determined by the color where you select the pattern feature and with the feature manager using select item 1 and 2 determine the setting of the tools, options, and colors. Coloring does not follow the same scheme, but as you see with in editing, creating the feature at those times the seed should be obvious and pattern instances are not shaded. To be able to visualize the seed without selecting the feature, some users manually change the color of the seed. Exploring geometry pattern options. Solidworks help file says geometry pattern option feature pattern results in faster pattern because it does not pattern with a parametric relation. The claim is valid only when there is an end condition pattern feature for the such of the feature will actually pattern the end condition's parametric behavior. The pattern shows in Figure 9.8 falls into this category. If you can turn on geometry pattern option, improve the rebuild with the time goes from 3 hundredths to 11 hundredths of a second, although 60% reduction is significant. Most compelling argument for use of geometry pattern has nothing to do with the rebuild time. It's avoid the effect of patterning the start end and condition parametrics. This ignores all settings of the feature definition. In effect, geometry pattern has much of the same effect pattern faces, but with some differences. Figure 9.8 shows a geometry pattern test. Geometry pattern off, parametrics are patterned, and then geometry pattern on, parametrics are not patterned. In fact, geometry pattern options intended the parenting existing geometry without parametric intelligence. Geometry pattern was designed to improve rebuild speed. Under some conditions, geometry pattern does not work. One example is in time of the pattern face merges on the faces cannot be patterned. Figure 9.9 shows the two patterns, one that can use geometry pattern and the one that cannot. Figure 9.9 shows merged faces, rebuild, selected features could not pattern using geometry pattern, deselect geometry pattern checkbox. Pattern rectangular bosses cannot be used geometry pattern because the face that is merged is not patterned to all pattern instances. Pattern of the truncated cylinder shown on the same part of the pattern of the rectangular boss can use the geometry pattern because the flat face is merged in every pattern instance. The circular pattern on the image on the right in Figure 9.9 also allows geometry pattern for the same reason. In some situations, SolidWorks error message may send you in a loop. As shown in Figure 9.10, one of the messages may tell you that the pattern cannot be created with the geometry pattern turned on. You should try to turn it off. When you do that, they may another message that says pattern will not work, or that you should try to use geometry pattern setting. In this case, like this, you try to use a different end condition feature that you want to pattern. Change the selection of the feature pattern along with this feature, such as fillets. You may also try pattern by its even faces rather than features. These last two options are covered in the following sections. Geometry pattern message. Rebuild features cannot be patterned using geometry pattern. Deselect geometry pattern checkbox. Pattern bodies. And it's covered multi-bodies from the depth. Chapter 311 model multi-bodies. We'll briefly discuss the topic here known as discussing patterns complete without the discussing of bodies. SolidWorks part contains the multiple solid surface bodies. A solid body is a solid that comprises a single continuous volume. Surface body is a difference of the thing in a sheet knitted together with its faces that does not have a requirement to enclose a volume, but it can also be patterned and mirrored as a body. There are more advantages and disadvantages of mirroring pattern bodies. Instead, a feature of the advantage can include simply selecting the single body for mirroring pattern. In this case, geometry to be patterned and complex with a large number of the feature patterning bodies also compute the faster. However, an example that was used earlier, table line 1, the pattern features 20 by 20 grid hole. When done patterning a single body 1 inch by 1 inch by half inch by half inch diameter hole patterning bodies gives a rebuild time about 60 seconds with or without verification rebuild function. Over the combined resulting bodies in a single body takes most of the time. This means for a large pattern of simple feature patterning bodies is not an effective technique. Although I do not have an experiment in this chapter to prove it, it seems intuitive that creating a pattern or a small number of complex bodies using a large number of features and pattern body would show a performance improvement over patterning the features. Another disadvantage of patterning and mirroring bodies is that it does not allow you to be selective. You cannot mirror the body minus complete features without doing some shuffling of the feature order feature manager. In addition, merge body options within the mirroring features does not work in the same way that it works in the other feature of the mirror of the only those bodies that are part of the mirror with the other bodies. These are part of the mirror. Pattern bodies do not have any option. Merge bodies, both of the function, all of them require additional combined features of solid bodies knit with the surface body to put in final result together. Some of the details may be obscure by the reading them about them, but when you begin to work pattern bodies trying to merge even the single body read over, then select again the inconsistent between merge open option existing in the mirror, but not in the pattern, as well as functional discrepancy between the merge in the mirror and merge result in. For example, extrude is unacceptable. Extrude is unexplainable as possible opportunity for enhancement request. Patterning faces. Most of the pattern faces have option patterning face option. A few restrictions. The main limitation being all the instances of the pattern must be created within the boundaries of the same face as original. Figure 911 shows example of the pattern faces option working in circular pattern feature. Alright, circle pattern using a pattern face option. The property manager shows the direction axis. Instance of spacing equals angle number of and around the number direction features bodies instance to skip obtain propagate visual properties full partial preview instances to vary direction 1 spacing to get around same limit face limitation you can knit faces together patterning them resulting surface body as shown in figure 912. 912 patterning a surface body. Well, now they've added a split in the face, which means the face from the feature on the side. It cannot be patterned all the way around. Pattern faces in another way of patterning geometry is Solidworks without pattern. Feature intelligence built into the original are the ways to make the patterns on imported parts of the existing geometry. Chapter 37 using imported geometry direct edit techniques. Address topic brief discussions on imported geometry direct edit techniques. Patterning face is not widely used the technique, however, should be somewhere in your toolbox of tricks, although it may be lurking near the bottom of the pile. It's useful in special circumstances. Patterning fillets. You may hear people argue that you cannot pattern fillets. This is only partially true. The true fillets for the individual features cannot be patterned. For example, if you have a symmetrical box and a fillet at one edge would want to pattern only the fillet on to the other edge, this does not work. However, the fillet is patterned with apparent geometry and perfectly acceptable and candidate for patterning. This is also true with the more complex fillet types such as variable radius and full radius fillets. You may need to use the geometry pattern option, and you may need to select all the fillets affecting the feature, but it certainly does work. Understanding pattern types. Up to now, I have discussed patterns and generally differentiated sketch patterns for the feature patterns, face patterns, body patterns. Look at some of the other factors affecting patterning and mirroring. In this section, I will discuss each individual type of the pattern to give you an idea of what options are available. When we discuss component patterns in assembly, keep in mind that the component pattern times are limited, but you can also feature the pattern from part to try with the component pattern in an assembly. Using a linear pattern, linear patterning has several available options: single direction, two direction. Direction can be established by the edge, plane, planar face, sketch, entity, axis, linear dimension. Two directions or either direction do not need to be perpendicular to one another. Spacing will represent the center distance between the pattern's instance that can be driven by a discrete spacing dimension or up to the reference where the software automatically figures out the spacing when you input the end reference minimum and offset distance in the required spacing. Reference of spacing can be figured out on feature centroid of the selecting reference such as vertex, edge, or plane. This is most important to get the correct relationship between the last instance of the up to and end reference. Number of instances, the number represented by the total number of the features in the pattern, which include the original seed feature, also can be driven by the equation. Equations are covered in detail chapter 10 using equations. These options are shown in figure 913. Direction 1 panel of the linear pattern driven up to a reference pattern. Show the pattern for a linear direction, space, instant up to reference. Centroid selected reference and then select reference, diameter, number, and dimension. Direction 2, second direction, just works like the first with the one exemption of the pattern seed only option. Pattern 914 show the difference between the default 2 direction pattern using one pattern seed only option. Using the default 2 direction pattern seed only option, so now we have the original feature with the pattern seed only. Instance to skip. The option enables you to select instance individual with the box as their lasso that you leave out of the final pattern on your monitoring pink dots. However, this instance of the remaining of the red dots are ones of the have been removed. Figure 915 shows the interface skipping instances. Pink is used for this instance to be created and gray for instances to be skipped. Propagate visual property option. Patterns, color, text, and cosmetic thread displays along with the feature which is attached. Very sketch. The option patterns are overlooked but are not widely used or understood, although it may have a niche application. Powerful option that can save a lot for the time open to the design possibility you may not have considered previously. Verily sketch allows you to sketch the pattern feature for the maintain with the parametric relation for the instant for the pattern and analogous for the geometry pattern. Geometry pattern disable the parametric end condition for a feature. Very sketch enable the parametric sketch relations for a pattern to activate with the very sketch option. Linear pattern must be linear dimension for its pattern direction. The dimension must measure for the direction of the pattern. Adding for the space for the pattern for the direction dimension must result in the valid feature. Sketch relation must hold for the entire length of the pattern. Figure 916 show for the sketch relation for the resulting pattern. Feature does not have a preview function. Alright, you varying a sketch option on the website to better understand how the feature works with the sample the file with the chapter 9 very sketch solid print for the materials downloaded as sketch 2. So this is the varying sketch option. Edit 4-inch dimension. Double click on it, scroll arrow, increase the dimension. Very effective with the sketch. Sketch does not react with the change properly. Can be used. Very sketch option. In this case, the 4/10 of an inch dimension is used for the direction because in the dimension to drive the sketch down with the pattern. When using the option, the feature for the sketch by driven in single dimension. If 48 hundredths of an inch dimension were anchored to the origin, the edge of the part like a 4/10 of an inch dimension, the pattern would not work properly. Direction dimension must be able to drive the sketch in the same way this one does. These dimensions cannot pass through the zero value, cannot flip the directions more than negative values. Whole operation is being driven with the construction line arcs and center lines of the sketch slots. If the sketch points over the model edges kept at a certain distance of the end of the slots using a half-inch dimension, the arcs are controlled by the equal radius relation within a single 58-inch radius dimension. Straight lines at the ends of the slot are controlled by equal length. The relation of the type of dimension relation to the creation is really parametric design is all about. The very sketch option takes otherwise a static linear pattern, makes it real parametrically in the way that would otherwise require lots of setup individual features. If you model everything in the level of care that you need to put into very sketch pattern feature sketch, then your models will react very well to the change. Instance to very different from the instance to skip and very sketch. All allows you to make various edits of the pattern with extremely powerful stuff. For patterning, refer to figure 917 for the instance of the varying property manager panel for the linear pattern feature. Direction 1 increments. Direction 1 increments control pattern spacing for the current direction for spacing x and second spacing xy and then x2y and so on. Using this option, spacing between the pattern involves either grow or shrink because the increment can be positive or negative. In the table below with the direction 1 spacing increment box, you can select additional dimensions for the pattern feature for the increment in the same way. In figure 917 you see pattern feature gets the further apart nearer or taller moved on the one side to each instances. This very gives a lot of power to alter patterns. And so we've now looked at the instance of very direction 1 increments, modified instances. So that's a very varies in your variance. Preview. Do not show the final variation instant unless the full preview toggle is an option panel. The advantage of using partial preview is a preview. Calculation speed, larger and complex patterns. Modified instances. Modified instance control other further modifications you want to make than individual instances. For example, the 917, you can see that one instance has been pushed to a side, one instance has been skipped. Familiar with the pink dots usually used instance to skip are also used here, whereas gray dot still means the instance has been skipped, but the green dot means the instance has been modified. I recommend that you edit the part with the download example of the file of the chapter up to the reference pattern solid part. Edit L pattern 1 feature to see set the colors and preview the full on your monitor. Alright, using a circular pattern. Circular pattern feature that requires a circular edge sketch with a cylindrical face, revolved face, straight edge axis, temporary axis, axis of the parent, axis of the parent, pattern axis of the pattern. Although other options are same in the linear pattern, except for the equal spacing option works differently. Equal spacing takes the total angle, evenly divide the number of instances into that angle. The equal spacing bit is misleading because the circular patterns create equal spacing between instances, but somehow everyone knows what that means, what they mean. Without using equal spacing option, angle setting represents the angular spacing between instances. Very sketch option, circular pattern as well. Principles for setup of the same. Most select angular dimension for the direction. The part shown in figure 918 was created using this technique. Alright, shows the circular pairing with varying sketch. If you're creative with a sketch relation, you'll be able to sketch. You'll obtain the sum of the petty with the exotic resolve of the pattern with a very sketch option. Instance of the very is also available with a circular pattern comparable to the functionality linear pattern we described earlier. Using a curve-driven pattern command is just what it sounds like. It drives the pattern along with the curve. The curve could be in line, in act, and arc, spline, the edge, and loop, in 2D, 3D sketch, even the real curve feature. Intersecting thing even about curve-driven feature is that you can have direction 2, and direction 2 can be a curve. This pattern type is one of the most interesting and has many options. For an entire sketch to be used as a curved sketch must not have any sharp corners. All of the entities must be tangent. This could mean that sketching fillets and or a fit spline. For example, shown in Figure 919, you created sketch fillets for the pattern with the equal spacing option, with space for the number of instances evenly around the curve. Also uses offset curve option, which maintains pattern feature relation with the curve throughout the pattern, as if the offset with the curve goes through the centroids. Each pattern instance with the line C with the option is used, which keeps all pattern instances aligned in the same direction. Curve-driven patterns and sketch fillets. Direction 1, number, equal spacing, dimension, curve, transform, offset, curve, align, method, tangent to curve, align to C, face, normal, direction, features, and faces and body, fillets, cuts and extrudes, and faces and bodies, instances, skips, option, geometry, pattern, vary, sketch, propagate, visual properties, full and partial view. Figure 920 shows the same with the heart with the transform, curve, position, option, tangent to curve, the line, option, alignment, option. Instead of an offset with the curve going to the centroids, each pattern feature for the instant of the transform curve of the entire curve of the move rather than the offset on the particular part. This causes a messy pattern with the tangent to curve. The option give the even pattern instant with the same orientation relative to the curve of its origin. Using transform curve and tangent curve options. Face normally option used in 3D pattern shown in Figure 921. Although this functionality seems a little obscure, it's useful if you need 3D curve-driven pattern on a complex surface. If you're curious about this example, in this material for the download, while file name, reference 3D curve-driven solid part. Use the 3D curve-driven pattern, and now we have kind of the whole thing. Using direction 2 curve-driven pattern creates a result similar to what is shown in Figure 922. Another situation with the rares go to know about. The rest of the curve-driven pattern command works like in other patterns that have already demonstrated. Figure 922 using direction 2 of it as a curve-driven pattern. Using sketch-driven patterns. Sketch-driven patterns are set with a sketch point for the drive, the location, and feature for the whole wizard drives location multiple holes in sketch point in a similar way. However, the sketch-driven pattern command does not create a 3D pattern in the same way that whole wizard does. In Figure 23, show the two-dimensional sketch-driven pattern. Reference point is not necessary for the first feature. Using a sketch-driven pattern, sketch reference centroid, selection features and faces, bodies, geometry pattern, propagate, visual properties, full and partial centroids, option, reference point, section find symmetrically, other easily definable shapes, circles, and rectangles where you find the centroid just looking at it, but in more complex shape. May want to use a selected point option. Using table-driven pattern. Table-driven pattern drives a set of feature locations most commonly holds from a table. The table may be imported in any sort of the two columns of the data. X and Y are separated by the space tab or comma. Extraneous data will cause import to fail. X and Y origin table is generated, determined with the coordinate system reference geometry. The X and Y plane coordinate system is plane which is XY data in the table of reference. You can access the coordinate system command with choosing insert reference geometry coordinate system from the menu, creating coordinate system, selecting combinations of vertex of the origin end to the line of the axis. Sketch-driven pattern with the command with the features can either control a selected point with a feature act as a reference point. The effect of this feature is still floating dialog points in the relatively low usage priority Solidworks upgrade schedule interface of the feature rather than crude in comparison to some of the more frequently used features. The interface is shown in Figure 924. Table-driven pattern, read a file reference from selected point, centroid coordinate system bodies to copy, features to copy, faces to copy, geometry, propagated visual properties, full and partial view, and then the table, the X and Y points. You can do the browse, save as, OK, or cancel, and go to the help menu. Using a fill pattern features fills a face or area is enclosed in the sketch with a pattern selected with a feature or seed cut. The type of the pattern used, the fill area limited to one of 4 preset patterns that are commonly used with the gratings, electronic ventilation, plastic, and sheet. Many of these patterns are author option fill pattern feature shown in figure 925. Using the fill pattern feature, they have a fill boundary pattern layout. Valid count feature faces selected feature create out of C cut, chamfer, face, body, instant, skip, option, geometry pattern, propagate, visual property, full, partial, prelude. The pattern layout panel enables you for the control spacing other geometrical aspect of the selected pattern layout as well as the minimum gap of the fill boundary for the most meaningful for the pattern regularity space feature for the regularity boundary using a variable pattern. Variable pattern command with combined with the technique with the table-driven pattern with the design table. Yes, you control all the parameters, multiple instances with the table pattern feature. The name might be misleading because there's no actual pattern, but the command just places a parametric copy of features whenever you want them. One of the biggest distinguishing characters of variable pattern command is that records failed instances the alternatives for the entire feature of the file rather than just a single instance, as will happen with the other pattern features. Alright, as you might accept with anything that is powerful, there are limitations. For example, if you will not allow the pattern hole wizard or other patterns, also it will not accept 3D sketches as reference geometry. Being such highly parametric feature for the variable pattern command tends to susceptibly some of the long-standing difficulties in Solidworks, such as getting directions fused with a spinning at an angle. Most example of the function you can see around the internet is listed with the 2D, but they don't really capture the unique capabilities, nor do they have any other compelling reason to use it. I have 2 examples for you here. One of the either abstract with the presented to show the concept, the other slightly more plausible application for the difficulty of spinning angles is reason most of the example is involved with the X and Y grid sort parametrics. You can get it to work, but it may be easier to do in a different way. Let's start with a simple example. Figure 9 showing the arrow-shaped feature placed on the curvy surface at a random point, rotated various angles. The feature is also extruded with the normal to the surface. Variable pattern function enables you to simply create multiple instances of the feature and apply different dimensions to it. It's like a design table where you have the possible configurations at the same time. This is a simple variable pattern. You waffle material solid print. Here's how this particular feature is set up. Section plane is offset with the end of the solid with a certain dimension, diameter 1. Selection plane, intersection sketch over the intersection curve of the section plate and with the curvy surface over the section plane. Move the intersection sketch will undilate. This is a sketch point intersection plane, sum of the distance, diameter 5, intersection sketch from left edge of the solid. Tangent plane is in the tangent of the curvy surface of the sketch point. Arrow sketches in the tangent plane of the arrow that can rotate change of the length, the drive, and the angle of the length, the dimension. Variable patterns are feature that can multiply arrow features simultaneously with various values of the following dimension parameters. 8.1 at the section position intersection sketch. 8.1 arrow sketch rotation arrow. 8.3 arrow sketch length of the arrow. 8.5 the intersection sketch position of the tangent point. Name variable pattern may be somewhat misleading because technically it's not really a pattern. There's no discernible recurring point pattern, just a collection of several versions, a single feature of the different position orientations. Let's move on to a more complex but less abstract example that will set up the same way, several parametrically driving entities that enable me to position the side of the orient one or more of the features that are placed in any of the parametric scheme allowed. In this case, I patterned with the flower around the regular shaped bottle. First try, but it didn't work well. It worked all except for getting the pattern all of the way around the bottle. If you only worked on the front half, shown figure 927, there here some of the instances where disjointed, which suggest the extruded features are putting off into space instead of toward the bottle. So I simplified applying the same pattern cylinder, which can more easily be done. In the circle pattern, I got the cylinder to work as shown figure 928. So now we have a pattern around irregular shape, works only on the front half, variable pattern, bottle cylinder. Variable pattern cylindrical works all the way around, variable pattern cylindrical solid parts. In the end, it was not able to work 100% of the complex geometry when the matter has been forwarded to Solidworks technical support issue. I got one row to go around apart all the way, and the other rows would project backside feature from the front. So there were no back features double from the front feature shown in figure 929. You can look at the file name variable pattern bottle 4 solid part. I feel like this has to do with the overall propensity of Solidworks to flip planes as they rotate. Alright, the reasons of all the internet examples of functions simplistic seems to be that not all really capable of fully functional 3D function. This appears to expose the underlying weaknesses in SolidWorks parameter function that have been there along. If you needed more complex patterning, you will need to make copies of the feature manually and using a mirroring a more conventional pattern. Cosmetic patterns, and we're going to cut the tape there.